Hello dear students, welcome to Pen and Paper Chemistry on YouTube as we continue with our topic on amines, and this is part 5 of the set of videos where we will be talking about the preparation of amines. So please make sure that you have your pen and paper ready for the next lesson. Preparation of amines can be done from a number of compounds, mainly by reduction. So we have the nitro derivatives, we've got the alkyl halides, we've got the amides, we've got phthalimide, which is again an amide, we've got nitriles, which can all be reduced to give us amines. We shall do the first preparation of amines by reducing the NO2 group. So NO2 getting converted into NH2. So it requires reducing agents. The normal reducing agents that we use is, we've got hydrogen using any of the finely divided inert metals like nickel, platinum, palladium. We've got hydrogen in the presence of palladium carbon in ethanol. Or we've got another method wherein we do not use any of the expensive metals. We generate hydrogen in situ, that is in the reaction mixture itself, because we know that these metals react with an acid to liberate hydrogen gas, and this hydrogen gas is going to act as the reducing agent. If you notice over here, I have written the combination of iron and HCl is preferred out of the three metals that are listed over here. Why is it so? In the case of iron, if you see, the reaction that takes place in the case of iron is Fe plus 2HCl gives me FeCl2 and hydrogen. Now hydrogen gas is liberated. You see over here we've got iron chloride. Now this iron 2 chloride can undergo hydrolysis, liberating more of HCl. So what is happening here is we are needing only a small amount of HCl in order to start or initiate the reduction process, and the rest is taken care of. And of course, as I mentioned, iron is out of the three metals listed over here, it is cheapest out of the metals. Let us now try and complete this reaction. Nitroalkane, on being reduced with hydrogen, what do you get? Would you like to try and complete this reaction yourself? I have put a question mark so that you can list the reducing agents in this. So we have, you can list over here hydrogen with the nickel, platinum, palladium. Like this, if you will list, it will be a good practice for you as well. Remember, I have already finished my exams, so I don't have to worry about anything. Your learning journey is just starting. So please make sure that you do your work sincerely. So what do you get over here? RNH2 and H2O. Same way, if you see nitrobenzene, so I am reducing an aliphatic nitro derivative and an aromatic nitro derivative. In other words, by this method, I can prepare aliphatic as well as aromatic amines. So aliphatic, yes, this is a very short topic. So I thought we'll cover the aliphatic and the aromatic compounds parallelly. Would you like to complete the reaction here? So this is our benzene ring, and NO2 gets reduced to NH2 and of course our water. Please list the reducing agents here for good practice. So as I've written here, aryl amines, yes, they can be prepared by this method. We will see that other methods cannot be easily used to prepare aryl amines. Why? Let's see. Now, so supposing you get this reaction as a conversion question, that's a very common question. So how do you convert benzene to aniline? So we have over here the starting compound. So we have benzene has to be converted to aniline. What is the series of steps over here? Benzene, nitration, and on further reduction. Now, I've written over here nitration. What do we bring about nitration with? What are the reagents used when we have to bring about nitration of aromatic compounds? Can you recall? We have done these reactions earlier. Yes, we use concentrated HNO3 and concentrated H2SO4 for nitration. What about the reducing agents over here? Yes, just now we've done 3 categories over here. You can write any of the reducing agents. You can even write iron and HCl over here. Why I am taking this example is, now that we are coming to the end of the topics of organic compounds, you see these type of reactions which we are studying under the heading of preparation can also be used to carry out conversions. So it's not necessary that you will be asked how do you prepare amine, ethanamine or methanamine. You could also be asked how do you convert nitroethane to ethanamine. So in that case, you write the starting compound, you write the final product, write the structure, and the reagents will automatically come to your mind, provided you have practiced your equations with pen and paper. Have you written it down? Should we move on to the next preparation? I can scroll it for you so that you can write it. Second method of preparation is from nitriles, again by reduction. So nitriles are C triple bond N. What are isonitriles? Yes, NC. If you recall, this is an ambident nucleophile where both the carbon or the nitrogen can act as the nucleophilic centers. We have discussed this in haloalkanes, so please go through that in case you have forgotten. So when we bring about the reduction of C triple bond N, how will it change? H, and here's an H. So if I have an alkyl group over here, or let me say if there is a carbon atom over here, it will change to CH2NH2. Look at what you had over here, R and a CN. This changed to RCH2NH2. In other words, the carbon which was part of the functional group now gets reduced and becomes a part of the alkyl chain. Although while naming, yes, we count it as part of the chain only, but here this becomes an CH2. So would you like to try? And by the way, what are the reducing agents? Yes, again we have either lithium aluminium hydride, or I should better write it as LiAlH4 in order to avoid confusion. Lot of places you will find it written as LaH, so do not get confused. Lithium aluminium hydride, or we have the second is hydrogen in the presence of nickel, or third one we've got sodium, amalgam and ethanol. Remember, we said that alcohols react with active metals to liberate hydrogen. So again our hydrogen is being generated in situ in the reaction mixture. Now go ahead and complete these reactions that you see on the screen. Tell me, can you prepare aliphatic and aromatic amines by this particular method? Look at the examples that I have given over here. Yes, very good. So aliphatic amines, yes. Aromatic amines, wonderful. Yes, we can prepare by reducing the corresponding nitriles. Did you complete the reaction? Do you want the products? Please make sure that you write the reducing agents. Yes, we don't use all of them. We can use either of them. So you see over here C2H5, CH2, NH2. The total number of carbon atoms is still remaining the same. 2 plus 1, 3. 2 plus 1, 3. How will you name this compound? Yes, how many carbon atoms are there? 3. So propanamine. Propanamine. Okay, what about this compound? C6H5, CH2, NH2. How do you name this compound? You see over here, this becomes our benzyl group, C6H5 and CH2. So this is benzylamine. And this is the common name. How will you name it as according to the IUPAC system? Yes, there's one carbon, and on that one carbon we have got a phenyl group and we've got an amino group. So I'll have it here, phenyl, because it is on carbon number 1, it is okay, I can leave it as well. There is no need for me to write the 1. So either I can put it or I can leave it, phenyl, and there is one carbon atom in the chain. So methanamine, phenyl methanamine, or even one phenyl methanamine would be considered correct. Did you get the name right? Wonderful. The next method of preparation involves haloalkanes or alkyl halides. Let me write it as haloalkanes as well. Haloalkanes or alkyl halides can undergo reactions in different ways to give us amines, but what kind of amines will be formed, that remains to be seen. So under haloalkanes, I will cover nucleophilic substitution of haloalkanes involving ammonolysis. Yes, does this name strike any, are you able to remember any reaction pertaining to this? Ammono comes from, yes, absolutely right, ammonia. So we had done haloalkanes reacting with ammonia. The second is, again, haloalkanes can be converted to nitriles, and just now we have written conversions of nitriles to amines. So that's the second way. The third place where haloalkanes are used is in Gabriel phthalimide synthesis. What is this reaction? We are going to do it in detail because it covers a part of our name reactions as well. But interestingly, you cannot involve or you cannot prepare aromatic amines. So in the sense, I cannot prepare aniline by this particular method, because if I have to prepare aniline, I will have to take an aryl halide and treat it with ammonia under extreme conditions. And still, if you recall, nucleophilic substitution in the case of aryl halides is very, very difficult, only under extreme conditions, which we cannot do in the laboratory because they do not like to undergo nucleophilic substitution. Why do they not like to undergo nucleophilic substitution? Again, recalling what we have done in the case of amines as well. We've got lone pair of electrons on the halogen atom, which it shares with the benzene ring, acquires a double bond characteristic. Our carbon is sp2 hybridized over here. With the result, it holds the electron strongly, and now it is difficult to break this bond and replace it with another nucleophile. Clear? So remember, these three methods where we are involving halogen derivatives cannot be used to prepare the aromatic derivatives of amines. So I have told you this important point because you need it for conversions. When you carry out conversions out of habit, if you are asked to convert C6H5Cl to C6H5NH2, our first inclination is to immediately react it with ammonia and in the presence of zinc chloride, and then I have this. Done. This will be wrong. How do we do the conversion? We will discuss a little later. Let us first focus on the amino derivatives of alkanes. So first is nucleophilic substitution using the method of ammonolysis. So I reacted the alkyl halide with an alcoholic solution of ammonia at 373 Kelvin. Nucleophilic substitution, remember, the positive and the negative, whether it is SN1 or SN2 remains to be seen, and then we have the electrons being donated by the nitrogen in ammonia, and we have the nucleophilic substitution. What is the disadvantage of this method? Yes, here you see, if there is an excess of haloalkane, my nitrogen still has lone pair of electrons with which it can entice, or with which it can, bribe the halogen over here and say, oh, see, I have electrons, why don't you take some electrons from me and do away with the halogen? And that is exactly what happens, and we have the secondary derivative of the amine. Still, nitrogen is not done away with its lone pair of electrons. Again, it can offer these electrons to the alkyl group of the haloalkane. The haloalkane breaks up its tie with the halogen, and we have the nitrogen with 3 alkyl groups, and we have a tertiary amine. Oh my God, look at that. This has still got lone pair of electrons. It's still not happy, which it can offer to, yes, the alkyl group. Now, when it offers to the alkyl group is smart. It says, see, you already have 3 alkyl groups. I can't trust you, so I am not going to do away with my halogen. And it keeps the halogen. Considering it from chemistry point of view, see, the lone pair of electrons are being shared with the alkyl group. With the result, my nitrogen now acquires a positive charge. Why does it acquire a positive charge? Because nitrogen, when it forms 4 bonds, look at the formal charge that the nitrogen will now have. It will have a positive charge. In order to balance that positive charge, it attracts a negative ion, which is, in this case, in the immediate vicinity, is a halogen atom, and we have what we call as the quaternary ammonium salts. So this particular method is giving me a mixture of primary, secondary, tertiary and quaternary ammonium salts. How can I prevent it? If you see, it is the haloalkane which is coming in every time, and because of which the nitrogen on the amine is able to share its electrons. What if this alkyl halide was not there? We supply the alkyl halide only in a very limited amount. So the reaction stops at only the 1 degree compound. Isn't it interesting? So you have, if you have the haloalkane in excess, you will get a mixture of amines, whereas if you have ammonia in excess, you will have 1 degree amine as your major product. Interestingly here, ammonium salts, on reacting with an alkali, they give you ammonia. Same way, amine salts that you are forming over here will react with NaOH to liberate the corresponding amine. Have you written all of this down? I am sharing the entire screen with you. Please go ahead. Please write down the reactions yourself. I hope by now you must have a separate notebook for chemistry, because you know that on this channel we have covered almost all the topics which are required to be covered for your examinations. Also do write the point about aryl halides, and notice something that I have done over here. You see, I have taken an derivative of an aromatic compound, but what kind of derivative is this? Here the halogen atom, so I have over here CH4. Replace one of the hydrogen by a halogen atom. Replace another hydrogen by a phenyl group. And I have what we call as benzyl group. So C6H5CH2. And then there is the halogen. So here it is chlorine. If you see here, the halogen is attached to the side chain. What carbon is this? Is it sp2 hybridized or sp3 hybridized carbon? This carbon is bonded to 2, 3 and 4. So that means it is sp3 hybridized. There is no double bond over here. Because it is sp3 hybridized, here this chlorine will be able to move out of this and be replaced by a nucleophile. That is why we said aryl halides. In other words, if I have the same chlorine attached to the benzene ring, this reaction will not take place. But if I have the chlorine atom attached to the side chain, in that case, yes, this reaction can readily take place and form the products. Please don't forget to write the condition of the reaction. I hope this is clear. Have you written it down? Where are the ammonium salts coming from? You see our amine NH2 group over here is still rich in electrons. So let me suppose RNH2. This is still rich in electrons. HCl. What can happen? It can form a salt RNH3 positive, Cl negative. And it is these amine salts which on reacting with an alkali, a strong alkali, will give you the corresponding amine and the sodium halide. Okay, clearing one point over here. A lot of us get confused between benzyl, benzol, benzo. So let me clear that doubt first. I have this compound over here, methyl derivative of benzene. So this is methyl benzene, or what is its common name? What is its IUPAC name or common accepted name? This is toluene. Remove one of the hydrogen, and I have what we call as the CH2 group, where the CH2 group can be replaced, the hydrogen can be replaced by some other. This is what we call as benzyl group. So C6H5CH2OH. This is all the common system of naming, but since it is very much prevalent, it is better to understand. So in this common system, this is benzyl group. OH is alcohol, so benzyl alcohol. You replace one more hydrogen atom over here, remove one more hydrogen. Now two free valencies are there. This is called as benzol. How do I remember? This is here CHO. You see over here the O is attached by a double bond, CHO. There are two valencies which are available to the carbon. Hence, this compound is also known as benzaldehyde. These are all common systems, names in the common system, but some of them are accepted by IUPAC. Remove one more hydrogen. Now there are three free valencies, 1, 2 and 3. Carbon can form 3 bonds, and now it is known as benzo. So CO C6H5. This is known as benzophenone. Got it? Because this is a ketonic group. You see over here C6H5, and then of course there is another C6H5. Clear? Look at the ketonic, look at the name, ON. That should be a hint to what the functional group is. I hope this makes it clear. You may want to copy this down. So to make it easy, I will put it as CH2. Would you like to note this down? Yes, it comes in very handy for a quick reference when you are preparing for your exam, or sometimes we do tend to get confused. Okay? The next method of preparation is very, very interesting, and I'm going to convert a haloalkane to an amine, but look at the number of carbon atoms. So I've got, let's say, n carbon atoms over here. In other words, let me say that I start with something like CH3Br. But look at the product. I'm forming CH3, CH2, NH2. I have one carbon atom over here, but here I have two carbon atoms. So how did this magic happen? I have increased the number of carbon atoms from 1 to 2. So that is called as going up the series. It is also called as ascending the series. And this is done by using the method of nucleophilic substitution. And how do we do that? Recall what we did in the haloalkanes. Haloalkanes react with alcoholic potassium cyanide, give you the nitrile derivative RCN. So Rx simply here, positive, negative, positive, negative, positive with the negative, negative with the positive. Simple. Let's try and understand it the easy way. No, I'm not doing it by the mechanism. Simple way to remember. And just a while ago, we did the preparation using nitriles. So nitriles on reduction with any of the reducing agents get converted into amines. So would you like to complete this reaction? C2H5Br plus KCN. What does it give you? And on further reduction, what do you get? Go ahead, try it. Give me the name of the product formed. Have you completed it? So you will get over here C2H5CN. And remember, alcoholic, because your haloalkanes are not soluble in water. I have two carbon atoms over here. Now I have 2 plus 1 carbon atoms over here, and this on reduction with lithium aluminium hydride or sodium amalgam and ethanol will give me C2H5 CH2NH2, which is an amine, a primary amine. Hence how will you name it as? Propanamine. Easy? Now, as we have said earlier also, aryl amines cannot be prepared by this method, as aryl halides do not undergo, aromatic halides do not undergo nucleophilic substitution reactions. But yes, if you have the halogen in the side chain, can you complete this reaction then for me? Go ahead, C6H5CH2CN, and this on further reduction gives you C6H5CH2CH2NH2. Now there are 2 carbon atoms in the side chain instead of just 1. So this becomes a derivative of, well done, it becomes a derivative of ethane. So I will name it as ethanamine, and at the first position I have the phenyl group. 1-phenyl ethanamine. Clear? The next method of preparation is known as Gabriel phthalimide synthesis. pH is silent over here, THALI IMIDE, imide group. That means NH group, not NH2. It's not amide, it's imide. Now, that means here I need phthalimide as one of the starting reagents. Here, phthalimide means it is coming from phthalic acid. Now, this is actually the common name of benzene 1,2-dicarboxylic acid. So, basically you have got two COOH groups at adjacent positions to each other in a benzene ring. Simple. Now, replace the OH groups by the NH2 group. In other words, we are forming a secondary amine here. Of course, no, we are not doing a conversion. This is just an easy way to remember. So, this becomes from phthalic acid, it is phthalimide. Now, this phthalimide is further, because its nitrogen has a lone pair of electrons, it should be a Lewis base or an acid. Yes, it is going to be a Lewis base because it's an electron donor. Electron donor is a base. But what happens if a bigger base comes into the picture and he says, hello boss, I am the one who's going to boss around and I am the one who's going to lead the show, not you. So what happens then in that case? This one is a weaker base. Weaker base means it is going to behave as an acid. So, because there is a stronger base present, this is going to be an acid. So, with the result, now if it is acid means it becomes proton donor instead of proton acceptor. And they form a potassium salt. So, the hydrogen gets replaced by potassium. So, the first step of our reaction is reaction with a strong base. Now, I have got the potassium salt of phthalimide. So, I had phthalimide. From phthalimide, I have got the potassium salt of it. Next step, nucleophilic substitution using a haloalkane. Again, positive, negative. Remember? Okay. So, we will have an alkyl derivative, but that alkyl is getting attached to N, to the nitrogen. So, this will be an alkyl derivative of phthalimide, an alkyl derivative of phthalimide. So, whatever alkyl group it is, so an ethyl and propyl, whatever alkyl group is there. So, third step, now I need to break this bond, and this is done by the method of hydrolysis. To make things simple, so you understand over here, hydrolysis means there's water. So, this is how it breaks H and OH. Here it is how it is going to break H and OH. So, I should get phthalic acid over here and a primary amine. But if you recall that we are carrying out this reaction in the presence of a base, and a base will replace the hydrogen by the metal atom. So, we will have metal ions. So, either potassium or sodium, whatever base we are using, which we had used in the first step. So, or because we are also carrying out the hydrolysis in aqueous NaOH or aqueous KOH, yes. So, that is why we will get the corresponding potassium or sodium salt of phthalic acid, and look at what we've got now. We've got a primary amine RNH2 as one of our products, and that is the whole target of this preparation, is preparing a primary amine. Interestingly, you can only prepare primary amines by this method, unlike the first ones where you could prepare secondary, tertiary, quaternary. And also, you see the steps, remember the steps. First step is reaction with a strong base where your NH behaves as an acidic group. Then is reaction with the haloalkane or alkyl halide. So, if I am taking an aryl halide, do you think it will undergo this step? No, because it's a nucleophilic substitution reaction. And third is hydrolysis with a strong base. So I will keep the screen for you. Go ahead, write the reactions. If you want, you can write the phthalic acid structure. You can leave it out also. This is only for understanding. It's only to make things easy for you. Even here, you can avoid writing electron donor, but since it is in the presence of a strong base, it will behave as an acid. I will write over here so that it is easy for you to relate to. Don't forget to show the lone pair of electrons. Yes, we are there. Go ahead, write the reaction. Don't forget to write the steps 1, 2, 3 so that when you want to recall immediately at the time of exams where we are panicking, these 3 steps written on the right hand side in short will help you recall the things easily. As we said earlier, you cannot prepare aryl amines as aryl halides do not undergo nucleophilic substitution reaction, which takes place in step 2. The last method of preparation involves the conversion of acid amides to amines. Now here you have to remember the 2 different ways that we can do it and get 2 different products. So when you carry out simple reduction, so reduction means the carbonyl group gets reduced, C double bond O, NH2, and the double bond O changes to 2 hydrogen and we will have CH2, NH2. The number of carbon atoms remains the same. This is on simple reduction of the amide group. The other what we call as the Hofmann's bromamide degradation reaction. Degrade means yes, you bring it down. So what happens in the case of Hofmann's bromamide reaction is that the number of carbon atoms reduces. So let's study them one by one. Again, I repeat, please make sure that you have your pen and paper ready. Amide, on being reduced, now the reducing agent is usually lithium aluminium hydride followed by hydrolysis. This gives you an amine having the same number of carbon atoms. So you had n carbon atoms of the alkyl group and 1 from the carbonyl. So total n plus 1. For example, if I have CH3, C double bond O, NH2. And I bring about its reduction with lithium aluminium hydride. Yes, that's my short form. So let me write it as LiAlH4 so that you do not get confused. Followed by hydrolysis gives you CH3, CH2, NH2. The number of carbon atoms 1, 2. Number of carbon atoms 1, 2. 2 carbon atoms. The total number of carbon atoms remains the same. The second method is where you have an amide and you treat it with the bromine in the presence of an aqueous or alcoholic strong alkali. Here the alkyl group moves from the carbonyl carbon and goes to and attaches itself to the nitrogen, and the nitrogen breaks its friendship with the carbonyl group and we have what we call as an alkyl amine over here. Hofmann's bromamide reaction, but can be used to prepare only primary amines. That means those containing the NH2 group. Okay, so we need to understand. So let us write the products of this reaction. Looking at this flow diagram, can you write the reaction yourself? And also try to write the reaction when you are taking CH3CONH2, the same compound that you took above, plus bromine plus NaOH in the presence of an alcoholic solution, and we will form now CH3 moves over here. So I have CH3NH2. The carbonyl group will form the corresponding carbonate with the alkali. The alkali also forms the bromide and water. We are not doing the mechanism of this. Look at the number of carbon atoms, 1 and 2. Look at the number of carbon atoms over here, 1. So in other words, we are going down the series. That means it is descending, the number of carbon atoms decreases. This is a very, very important method, especially when it comes to conversions. That is the reason it is known as degradation reaction or Hofmann's degradation reaction. And you can prepare alkyl as well as aryl derivatives from using this particular method. So go ahead, form the corresponding amines. So you have to form CH3NH2 using CH3CONH2. No. Okay. Form. Okay, using Hofmann's bromamide reaction, how can you prepare aniline? And which method will you use in order to prepare this amine? Go ahead, try it yourself. Would you like to tally your answers? So we prepare methanamine using Hofmann's bromamide reaction, and we will have, what is the name of this compound? The starting compound would be ethanamide. Look at the number of carbon atoms, 1 and 2, and the functional group is an amide functional group. Same way, this is benzamide. And lastly, it is preferable to prepare this compound using benzamide and we carry out reduction. Now look at the difference in the products formed. I have specifically taken this example using the same starting compound but different methods, you get different products. Reduction, the number of carbon atoms remains the same, but Hofmann's bromamide reaction, the number of carbon atoms reduces by 1. And this carbon atom is the carbonyl group 1, which goes away. What about the side products? I hope you have written the side products for this reaction. And I also hope that you have been noting all of this down while we were doing it. And this concept of the preparation of amines is clear to you. Next video, we shall be talking about the properties of amines, their comparison of boiling point, melting point, and so on, and some chemical properties as well. So stay tuned, stay connected, keep the same notebook for yourself so that your notes for offline reference are ready. See you in the next video. Take care till then.